Hi guys, we're back here with another application problem on quadratic functions. In this case, we want to write a quadratic function in the standard form when we already have 3 points that are already provided to us. Okay, so guys, the 3 points that I have is that the curve of this graph passes through is one is 0, 0, -1, -2, and 1 and 6. And let us see how we can use these points to write the equation in the standard form. Before we start writing the standard form, let us recall that standard form looks something like this. F of x equals to ax square plus bx plus c, okay? And we know that we don't want a to be 0, right? Because then it will become a linear function. So let us see how we can use these points to write the equation in the standard form. So the first thing we're going to do is we're going to try to start using the first point, then second, and then the third. So we obviously know that when the x is 0, the corresponding y is 0, and same thing for this. When the x is -1, the corresponding y is this, and x is 1, and the corresponding y is +6. So I'm going to write this quadratic standard form. It's y equals to ax square plus bx plus c, right? Now, when this point, so we know that the graph passes through point 0 and 0. So that means when the y is 0, then what is my x? So the corresponding x is 0, right? So it's going to be 0 square. Then I'm going to put plus b. X is still 0. And then there is a plus c. Guys, we simply wrote the standard form. And then based on the given point, we just substituted the values for x and y. That's all we did. Because let's go back to the standard form here. Guys, to write an equation in the standard form, what we basically need to know is what are the values of a, b, and c, right? And all the work that we're going to do right here is just to figure out a, b, and c. Once we have a, b, and c, we can write the equation in the standard form, right? So let's see what happens when we simplify this. Okay, I have 0 on the left hand side. Well, 0 squared is 0, so a times 0 is 0. So this term vanishes. Same thing with this, b times 0 is 0, vanishes, so I have just plus c. Hey, look here, I just got the value for c. I already got, I'm already 30% done because I have to find a, b, and c. I already have the value for c, and that is going to make our life easy because now we already know that c equals to 0. Okay, so we already figured out one variable just by using the first point. Now here I must also mention the fact that I did not choose a very complicated example. I decided to choose something which passes through the origin because 0, 0 is like the origin, so that makes life a little easier. But can it still be done with a point different than origin? Yes, it can still be done, and you should try some examples like that. And if you are stuck, let me know. I can go over some examples here as well. Okay, so guys, that is my c. Now let us use the second point and see what we can figure out from there. We already know the c is 0, so we don't have to worry about c anymore. So let's use this point. So same equation, right? Y equals to x squared plus bx plus c. So when y is -2, then what is my right hand side? So right hand side I have a, and then I have x squared. For x I have to replace x by -1 square, right? Because x is -1. Then I have plus b times x, and x is still -1. Do I have to worry about plus c? No, because c is 0, so I don't need to really write it. Guys, let us simplify this. So I have -2 equals to -1 square is what? -1 square is +1, so it's just going to be a, and positive b times -1 is going to be -b. So, well, we were not able to figure out a or b from this equation, but let us just preserve this equation. We have a minus b equal to -2. Okay, let's just preserve this equation and let us move on to this third one. Let us use the third point and see what happens. For the third point, we do the exact same thing. We substitute for y and x on the left hand side and the right hand side and see why does that lead us to. So for here, we have, I have what, I have +6 on the left for y, and then I have ax squared plus bx. I don't have to worry about the c. So I have a times, what do I have here? 1 square. You can still put it in the parentheses. And then I have plus b times, again, +1, right? Now let's simplify. This is 6 equals to 1 square is 1, so a times 1 is just a, and then plus b. Again, just put it in the box. The first equation helped us to get c right away. Well, we were lucky because it was the origin, so it isolated a and b, and we were able to get C by itself. For equation 2, we were not able to find A or B, but at least we were able to get a simple linear equation. Same thing with point 3. We were not able to calculate A or B right away, but at least we have a linear equation. Guys, now this is an equation, this is another equation. We have two equations, and that means we have a system of equations. And do we know how to solve a system of equations? Yes, we're supposed to know how to solve them. I have already uploaded a lot of videos about the system of equations. So by now I'm sure, like, if you have been watching my videos, you would already know how to solve a system. But guys, if you don't, then please go back and first visit my video on solving system of equations, because we covered a lot of them. We even covered system of 3x3 equations as well. Here it's only 2x2. Okay, so please see that, and then you come back here and you try to finish this exercise as well. But here I'm just also going to show you how to actually do it. So what I'm going to do here is I'm going to rewrite these two equations, and we know we want to write them one above the other. We want to just align the A's and B's vertically. So again, the other one is, what is the other one? A minus B equal to -2. I'm just rewriting them, and we know, like, when we have the system, we like to write them in this form. We like to write the one equation and then the other one below it, and we want to match them vertically, right? So guys, once we have it, I think the best way of solving this would be just to add both the equations, which takes us back to the method of elimination, right? So if I add these two equations, because I see this is plus b minus b, so right away if I add those two, they will cross out and we can isolate one of the variables. So let's do that. So this crosses out. A plus a is 2a, and on the right hand side 6 minus 2 is 4. And by dividing both sides by 2, I can get my a equals to 2. Guys, I have my c, I have my a. I mean, I can go back to this equation or this equation to find my b, and I'm almost done. So let us use, it's up to you which one you want to use. So I'm going to use this one. For this one, I got 6 equals to 2 plus b. And from here, I get b equal to 6 minus 2, which is simply 4. Guys, I have a, b, and c. Let us go back and finally write our equation. So our equation looks like this: y equal to ax squared plus bx plus c. So my final equation will be 2, and then I have x squared, and then plus 4, because b is 4, x, and then there's a plus 0, which you do not really have to write. So you can think of, or you can write the final equation as simply 2x squared plus 4x. That is my final equation. That is my final equation in the standard form: ax squared plus bx plus c. What is my a? A is 2, b is 4, and c is 0. Okay, and if you have to convert this into the vertex form, you already know how to do that as well. Okay, so guys, this is another application problem. I'm going to do more problems, more application problems in the next videos. Till then, just keep practicing, and if you have any questions, please feel free to reach out to me.